So today we are going to discuss a concept called artificial neural networks. This is one of the important concept under AI. See, these are the inputs. It can be a dog, it can be a horse, it can be a tiger. Now, any image, when we are bringing in front of the human eye, how the human eye perception will be there. It will process, it will observe an image, it will process it. What kind of image it is, it will match the patterns, whatever already we know it. From the childhood onwards, whatever we have heard or whatever we have learned, okay, so that pattern matching will happen. If eyes are like this, if ears are like this, and the shape is like this, and if the face is like this, maybe rabbit is also looks like the same. Okay, rabbit is also looks like the same. Okay, rabbit is also looks like the same. But few differences we have to recognize that this is a cat and that is a rabbit, right? So that you are able to recognize the things, you are going to match the patterns, and finally you are able to conclude that this is a cat. Okay, how this human brain. So artificial neural networks is nothing but how a human brain will process the information. As soon as we have seen any kind of images, or as soon as we get the any kind of sounds or any kind of perceptions or cognitions, you'll be able to map the things, you'll be able to understand the things, and how this information gets processed, and how you will be getting the replies. For example, as soon as you have seen an image, you started thinking that I have seen him somewhere else. Okay, I have seen him somewhere else. Who is he or who is she? You started recollecting the things. So your brain started processing it. Your eyes has given certain image to your brain, and brain started thinking, and finally somehow it will process the information, and you'll be able to get that this person is so and so. Yes, I have seen this person at so and so place, or so and so function, or so and so school or college. Okay, like that information will be able to process and will be able to give the response. So how this human brain will work the same way, why can't we introduce a concept called neural networks, that to artificial neural networks, so that a system can be able to think, can be able to map the things, can be able to give the reply as soon as you have shown an image. So that comes with this neural network. Artificial neural network is a computing system inspired by analogy of biological neurons, which is used to process the information as human brain does. So this process will be just like the human brain, how the human brain works, or how the human brain thinks, or how the human brain process the information. So from there, this artificial neural network comes into the picture. So just now we have seen here in this part as a brain, the input is same and output is also same. Only the thing is changed here is Here earlier it is brain. Now this is a artificial neural network system. Okay, where this particular things are processing. Forget about what we will call here, but this is an input, this is an output. The neurons comes under input is input neurons. The neurons comes under output is output neurons. So this is output layer, this is input layer, and this is a processing area. Generally, ANNs use feed-forward network, which consists of different layers, namely input, hidden, and output layers. So generally, we'll be having feed-forward neural networks. Okay, feed-forward means, as we have seen in the earlier picture, see, you are feeding from here to here. So this is a forward direction, right? From here to here, here to here, and here to here. So this is a forward direction. So data will input will be comes from here, and this will be processed here, and that processed information will be sent here, and again this will be processed, and that finally gives the output. Okay, that is what it is saying. Use feed forward network, which consists of different layers. One is input layer. This is called as hidden layer. This layer, how many hidden layers we have? We cannot say just like that. According to the complexity of the problem statement, we'll be able to decide that how many hidden layers we require here. So generally, we'll call this is a hidden layers. This is input layer, and finally this is an output layer, as I said. So this will be a hidden layer. So in this hidden layer, we have two hidden layers. One is H1, this is H2. So I'm not saying here that we should have only two hidden layers or three hidden layers. It depends on the complexity of the problem. That will states that how many hidden layers we require. Before going to discuss what exactly all this ANN, let me explain you first about your biological neuron and biological structure. Then we'll go back to the artificial neural networks. As you all able to remember this, this is called as neuron. In our 10th standard, we used to draw this. If I'm not wrong, right? We all know this, right? Yes or no? Yes. So this is what our neuron. Okay. See, from here, we'll be getting inputs. So we have almost 10 power, if I'm not wrong, 10 power minus 11. Those many neurons we have in our human body. So out of which each neuron is interconnected with the other neuron. From toe, from our leg finger called toe to till brain, till your head or brain, we have several neurons. And several neurons, and see, and how how much fast the process will be. See, somewhere at your leg, some mosquito is biting, or some mosquito started stinging. Okay, immediately within a fraction of second, that information will be reached to your brain, that exact including exact GPS at which place the mosquito is stinging, including GPRS. It will give the information. Immediately it will gives the information to our eyes, and eyes started watching on it. And at the same time, it will gives the information to your hand, and hand started beating. Okay, hand started beating, or hand started its process, so that the pain will not come. See, somewhere the mosquito is started stinging, that information is processed to your, like sent to your brain, and brain started processing it and given the exact inputs to the respective actuators. So the first instruction given to the eyes, and I started watching. Immediately after watching your eye, the same. Now eyes worked as a camera, and that information will be given to hand. Exactly, eyes is giving information that here. Now hand started processing. Though sometimes without watching also, you are going to a correct location and you started beating on mosquito. So how wonderful this entire structure is made. How wonderful the entire structure is made and how wonderfully the system is working. And the communication in between the organs, the processing the organs. See how good it is. Okay. So how this entire things are going to be happen means through your neurons. So neurons will be giving the information to the brain and brain started giving the instructions to the respective actuators. So that information from somewhere toe to brain, how this information will be passed? Neuron to neuron, neuron to neuron, neuron to neuron, that information will be passed. Okay. See, so these are inputs. Okay, so these things are connected with some other neurons. See here, so this will be connected to this neuron, this may be connected to some other neuron, this may be connected to some other neuron, like that it will be get connected. Okay, and this is what your cell body, and this is your nucleus. So, and see here, this will be get summation. So this will be called as axons. So this is dendrites, axons and synapse if I am not wrong. See, these are dendrites, this is cell body, these are axons and this is synapse. So dendrites will gather the information from various other neurons and through cell body everything will be like everything will be combined here and this information will be processed here and this processed information will be passed, like this can be the output. Synapse will be worked as an output and each synapse is connected with this with some other neuron. Each synapse will be connected with some other neuron. Okay, so like that information will be sent to the brain within a fraction of seconds. What is an artificial neuron? Now synchronize the things. Whatever you have understood in your biological neuron, now connect that biological neuron concept to your artificial neuron. Okay, connect that to the artificial neuron. So see, these are dendrites, what we have seen in your biological neuron. These are dendrites and this will be called as here inputs. Okay, so it will take all like all input values and get some like you are going to combine here. Here you are going to process. Finally, you will be getting the output. The same thing. This is input. Here W1, W2, Wn. I'll explain you this. Why this W1, W2, Wn is required. This is what your activation function through which you will be getting your output. So this output value can be continuous, binary or categorical. Output value can be continuous, binary, categorical. Continuous means, for example, so continuously you have some changes. Either it will be increasing or it can be decreasing. For example, stock market. Stock market or share market, when you are taking, okay, so each what we'll call each day's share, like one particular share price, when you are considering, each share cost or price will be goes up or down. That we can't say that that will continuously increasing or continuously decreasing. Again, it depends on the various other factors, and I'm not going to concentrate on the factors. I'm not going to concentrate on the factors by which the share market will increase or decrease. But I'm concentrating on the price. Price here is my variable. So this price or the cost will continuously increase or continuously decrease. Okay, continuously increase or continuously decrease. So that is what you will be called it as continuous output value. That output value continuously changes. Either it can be increasing or it can be decreasing. So that can be one of your output values. The other one is binary. Binary means yes or no. Here you have two values. 0 means no, 1 means yes, true or false. So such values you will be call it as binary. Example is any healthcare data when you are taking. So COVID positive or negative. So whatever it may be, various factors are involved. He is having fever, he is having so and so age, he is having certain throat infection, he is having cold, he is whatever. Some people may not have cold, some people may not have throat infection, some people may not have fever. So whatever it may be, finally the result is positive or negative. So 0 or 1, such kind of data will be called as binary data, or you may call it as discrete data. Okay, your output value can be discrete or binary. And the third one is categorical. Categorical means category. Like for example, different categories. Uh, like so, you have a group of vegetables. So few vegetables comes under circle category. Few vegetables comes under straight line category. Few vegetables comes under um, oval category, or you may call it. It's like that. So which category it comes under? Categorical. So you are categorizing the thing. So these are rich people, these are poor people, these are average people. Like that, you are categorizing the things. So he's a good customer, he's a bad customer, he's an average customer, he's an excellent customer. Okay. So such categories when you are when you are going to recommend the songs, recommendations, movies recommendation, songs recommendation. So sad song lovers and like melodious song lovers or a little beat sound lovers. So it can be categorized the people accordingly, and it will able to recommend certain certain songs, movies, or certain things will be recommended. So that is what your output values. Output values can be continuous, can be discrete, can be categorical. Yes. Artificial neuron is also called as perceptron. Artificial neuron is also called as perceptron. And this will be called as node. And we'll compare. So the names. So here we have soma. Soma will be called as node. Dendrites will be called as input. Synapse will be called as weights or interconnections. Axon will be called as output. Now, how this perceptron will works? How this perceptron will works? That we'll see now. As of now, if you have any doubts, you can ask. Any doubts? Okay, ma'am. Thank you. So how this perceptron will works, we'll see. Because here we have inputs, weights. I'll tell you what is this weights and all. So, okay. And this is what output. What exactly happens here so that you'll be getting your outputs. Inputs, weights you are giving. What is happening here so that you'll be getting the outputs. So working of a perceptron. See, for example, I'll tell you why these weights are required. Okay. And then I'll go for working of perceptron. Okay. So I told you that your eyes will give some information every time. Still, how many hours your eyes are open, that many hours, continuous information will be given by the eyes. Yes or no? So how many hours you have open? You are in open mode. Okay. You are in open mode. That many hours, your eyes will give the information. Will you accept that? Continuous information will be passing from your eyes to your brain. It will gives the continuous information because every second you are watching something or something or some other thing that will be given to your brain. Your ears will be giving some information. It will hear sounds, plenty of sounds will be heard, and that information is also passed to your brain. For example, this is what our brain. Imagine that I'm not a good artist to draw the things particularly, but imagine that this is what your brain. Okay. So your eyes is giving certain information, your ears are giving certain information, and your nose may be giving certain information. Apart from these three, your skin, your skin is worked as a sensors, right? Your skin. So each cell, maybe your legs are touching the floor is too cool. Your hands are touching the pillows or your hands are touching something or some other thing which are rough or smooth or itchy or something else. Some information will be passed by your skin. Your tongue is saying something, you want to eat something or you are eating something, it is too hot or too cool. Some information will be given by your tongue, some information, each cell is giving some information. Apart from that, even your internal organs are passing some information. You require a glass of water. So your body feeling like your body feeling some dehydration, it required some water. Your stomach feeling something. So even some internal body organs are giving certain information. Your mind is saying to watch certain movie. Your mind is asking you to go somewhere. Like that, what happened? Every body part or every organ is saying some information. Yes or no? Tell me quick. Am I correct? Yes. So like that, every time, every part, every body organs are passing. But out of these much informations, continuously flowing the information, continuously flowing the information from here to your brain. Now, your brain has to think and it has to give the attention to which information it has to pay the attention, which information it has to respond immediately, which information required the priority, which information required highest attention or more urgent attention is required. Okay, so that your brain has to think. Okay, that your brain has to think, and it has to attend to that particular task immediately. Okay, out of these much information, to which information its attention is required very urgently, that information has to be identified and has to be respond immediately. So that is what we will call here weights. Weights are giving such information. Based on the weights, it will get decide that which neuron is required immediate attention, immediate response. Okay, so that is what your weights. Okay, now we'll see how to work with your perceptron. So working of a perceptron. Initially, what is the first step here? Initially, initialize the weights near to 0 but not 0. This is an important point. You need to initialize all these weights to near to 0. It can be 0.1 but not 0. But not 0. It can be near to your 0, but it should never be 0. Inputs are multiplied with respect to its weights. Okay, so for example, this is what your first semester marks, these are your second semester marks, these are your third semester marks, these are your fourth semester marks. Now we are expecting fifth semester marks. You want to predict your fifth semester marks. So you are combining your input values to your weights. You are multiplying your to your weights. Okay. Then finally, what you want to predict? You want to predict your fifth semester marks. So what it is asking, how to predict this fifth semester marks, we'll see later. But the second step is all input values will be combined, will be multiplied with the respective weights and taken sum. And their respective sum is taken. So sum of I is equal to 0 to n. So here n value is 4. Xi and Wi. All weights will be multiplied. Either you can write Xi Wi or Xi into Wi. So this is the meaning of this particular step. First step, what it is saying, you need to initialize all weights near to 0 but not 0. Once you have initialized, then what you want to do? You want to multiply. You want to multiply the inputs with their respective weights and take their respective sum. The sum is passed through an activation function to get the resultant function. So this sum is passed through an activation function. So activation function, again we have several activation functions. It can be sigmoid, it can be threshold, or it can be ReLU, whatever it may be. We have several activation functions. The summation value will be passed through the activation function to get the result. Result is nothing but y. Step 2, the same thing. The sum is passed through an activation function. This activation function is depends upon the concept. So if you are taking images, so it can be a ReLU or sigmoid. Like that, we have certain instructions. So which activation function you need to take? The activation output is considered as resultant output. This output, whatever the value will be coming from your resultant, activation of function will be called as your output. This is nothing but your working of a perceptron. See, this is what step 1. I is equal to 1 to m wi xi into wi or wi or xi, anything is okay, anything is same. 2 into 3 or 3 into 2, both are same, right? Now step 2. Step 2, what we said? So we are passing that through our activation function. Step 3 is our output. Why waits? Just now I told you, no? So we are taking a real-time example. So we have experience, we have a loan. What would be his salary? So I am saying his experience. He is having 10 years of experience and he is having 50 lakhs loan. Can you people are able to identify what is his salary? Can you? Can you people are able to say his salary? Yes or no? Are these values are enough to say his salary? No, right? So these two values are not enough to predict your salary or to say your salary. We can't say his salary. Sometimes I can go for 50 lakhs loan. Like if I'm a government employee, I can go for 50 lakhs loan and I'll put all, like throughout my service, I want to deduct the EMI. But we can't say that 50 lakhs loan, if he is going, then his salary should be monthly 1 lakh. We cannot predict like such things. Okay. These two things are not enough. Or I want to say something else like, yes, when you are going to the interviewer, when you are going to the interviewer and you are saying that I have 10 years experience and I have 50 lakhs loan, give me 40 LPA per annum or 25 LPA per annum. Can you able to say this? That, and that also no, right? So here we cannot showcase our loan. We cannot showcase our loan, rather than we need to showcase our experience. I have 10 years of experience. I have 10 years of experience and I know so and so. Then my expectation is so and so. You can say like that. Okay. Will having loan affects the salary? So, what is your answers? Will having loan affects the salary? Yes or no? Having loan affects the salary? Okay. So, according to our perceptions, in like what way we are taking that? If I'm taking that, yes, I'm crediting this much salary, and my salary again affects the, like, loan affects my salary because some deductions will happen from my salary. Due to that reason, you people may say yes. But if I'm taking in another aspects, I have gone to an like interview, and there I sat, and finally, when they are discussing the salary, you said that I have 20 lakhs loan. So whatever salary you offered is not sufficient. Can you give me 10 lakhs more? So 20 lakhs you offered, and I'm expecting 10 lakhs more. So can I say like that? Can I say like that? So you offer 20 lakhs, but I have 20 lakhs loan, which is not sufficient. Like whatever salary you offered is not sufficient. Increase my salary more 10 lakhs or more 20 lakhs. So how many of you are saying yes? But no, you cannot say that. You cannot say like that. Okay. We cannot showcase our loan to increase our salary. Okay, which will never affect your salary. So here, the perception, what way you are taking this example is matter. Okay, according to that, you'll be having your answers. So here, which one I need to showcase? So in front of me, I have two things. One is my very good experience, and in other hand, I have loan. But I should not showcase this loan. So I'm giving less priority to this loan and giving highest priority to my experience. So I need to showcase my experience. It will be affects the salary purchasing or salary the things. Okay. So based on the experience, I have 10 years experience. How much salary will I get? That you can expect. The person who is having 10 years of like industry experience, you can say, yeah, he may have 25 to 40 LPA. We can guess the things. So he worked as a data scientist in a Wipro, means you can expect 50 to 80 LPA. Wipro or any MNC, you can expect their salary. What would be his salary means you may have the answer, right? Okay. And when when the problem is like, will having loan affects the salary, and what is his loan and how much it affects the salary, then loan will be having highest priority and experience will be having least priority. So according to the scenario, that will decides which one has to be given the highest priority and which one has to be given the least priority. It depends on the situation to situation. You cannot say that every time the same priority will be given. You cannot say like that. It depends. Theoretically, weights determine the importance of inputs, and mathematically, weights are just the slope of the line. When you are taking linear regression into the picture, so y is equal to mx plus c. Here, weights are taken as slope, due to which your y value varies, your outputs varies, right? Y activation function is required. So we were discussed about inputs. We were discussed about weights. And combining these two, what we are doing, we are passing these weights to activation function. Yes. So you are passing these values to activation function. Now, why this activation function is required? That we need to discuss. I'll explain you that also. Just a second. I'll connect my mouse. Okay. See the diagrams here. Generally, okay, generally, so this is what my y and this is what my x. When you are taking the values, if I have two different clusters, one is x1 and x2. Okay, so x1 cluster is all circles. Y1 is, for example, all plus. I'll change the color, which all plus. Like this. Okay. And now, if I'm able to divide these two values using a single line, okay, if I'm able to separate these two values, x1 and x2 clusters using a single line, then this will be called as linear separability. Linearly separable. You have separated these two different clusters using a single line, then this will be called as linearly separable. Okay, any line. Okay, you can draw like this, you can draw like this. Okay, any line, but you need to separate. Okay, so I'm not saying that you have to take the line like this only. Any line. Okay, any line you can use to separate these two clusters. This will be called as linearly separable. Okay, but see here, when you are taking this diagram, see, so how can you separate this? If I separate this like this, no. I can separate like this, no. I can separate like this, shall I able to separate like this? Whatever the directions you are taking, but you are unable to separate these two clusters. You are unable to separate these two clusters. So one is red cluster, the other is green cluster. So I have red plus and green plus, two different categories I have, but I am unable to separate these two categories using a single line. Are we able to separate these two different values with any with a single line? Do you have any solution here? Can we able to separate? No, right? So this is non-linear separability. Using any single line, you cannot separate. And then here we required this activation functions. Okay. Generally, in linear regression, when we are discussing about linear regression can be able to separate two different clusters using a single line. Okay. There we don't have any solution for this kind of problems. But in your artificial neural network, we have a solution. Like here, activation function is the solution. Using this activation function, you'll be able to separate this kind of data also. How we are able to solve? See here. Data points are not linearly separable. So now this data points or this kind of maps or this kind of graphs or this kind of data, you are passing to a higher dimensions. Here it is a 2 dimensions, right? Where we have x1 and x2 or x and y. Now these things you are moving towards to the higher dimensions that can be 3D or 4D. Two-dimensional data is moving to the higher dimensions so that you will be able to separate two different kind of data or to like this kind of problem get resolved. See, so this is what your 2D space. Now this data you are passing to 3D space where we have a hyperplane. This hyperplane and three-dimensional data, what it will do? It will be able to separate your data points to two different clusters. Here I am not going to use any line. Linear separable lines I'm not using. I'm not using any linear regressions. I'm not using any y is equal to mx plus c, which is very impossible in this kind of problems. Here the only solution is you need to move this data to three-dimensional data, three-dimensional space. Then there automatically by using your hyperplane, it will be able to separate two different clusters. Okay, you are able to separate them using hyperplane. That is what initially activation function x1 comma x2 is equal to x1 comma x2 comma z. So for this we required activation function. So this activation function will transform the data from 2D to 3D to separate the data points, to linearly separate the data points. So due to that, your neural networks got more attention because of this activation function. Without activation function, neural network is waste. Neural network is simply like your linear regression. That is the point I have added. See, activation function is used to transform in non-linear separable data to linearly separable data, which helps to learn and perform more complex tasks. Without activation function, neural network is just a linear regression model. Without this activation function, your neural network is just linear regression model. Types of activation functions. We have threshold function, we have ReLU function, we have sigmoid function, we have tanh function, we have softmax functions. So the softmax functions, tanh functions, ReLU functions, wherever your neural networks are using, you are going to use these functions. So as soon as activation function, like some activity is triggered, okay, when the value, your x value becomes 0, automatically what happens? Your result will be moved towards to the 1. Okay, so this is what? If x is greater than or equal to 0, 0 if x is less than 0. Okay, so that x is your input values. And even softmax, when it is a probability oriented data, we'll go for softmax, sigmoid functions, and tanh functions. See, each individual activation function, these are the formulas. No need to remember because in your Python, we have we are going to use simply ReLU. Automatically, that ReLU mathematical function will like comes over there, and it will apply your values into the formula, and it will get substituted and getting the values, and the values will be displayed onto the screen. Simply the thing we are going to do here is we are going to call ReLU function and passing the values. That's it. Okay. So ReLU function generally it will take maximum value. Q of x is equal to max of x comma 0. Okay. So x comma 0, out of which the value is maximum, that value will be considered as an output. So these are your activation functions. Let me remove this. How does ANNs learn? So how this artificial neural network will learn the things. So these are two different clusters. One is banana, x1 is banana, x2 is orange. Now how we are going to separate these two clusters? If I'm using like this. If I'm using like this, are you able to separate two different clusters? Error is 3. You have not yet separated. So you'll be getting errors. So based on that, what you are going to do, you have your inputs, you have your weights, and you are separated two different clusters. But actually what happened? You got certain error here. Okay, by seeing the error, you need to retune your weights. Okay, you can't tune your input values. Input values you can't train. Instead of bananas, you can't put all oranges. Or instead of oranges, you can't change all bananas. So you can't modify the inputs. Rather than we need to modify what? You need to modify the weights. So that what happened? So earlier case we have error is equal to 3 means when you are fine tuned your weight so that your error will be reduced at least 2. Reduced to 2. Then what happened after fine tuning? This is the case. This is the case. Then what happened? Now you got error is 1. Now your banana is, so here what happened? Yeah, you got 1 error. Okay. So this is not like maybe when you are taking these two as a clusters. 1, so this 2 is becoming 1, this 2 is becoming 1, these 2 is becoming 1. This is a separate one. So your error gets 1. Still what you need to do? You are fine tuning your weights. Finally what happens? See, you got your error minimum. We should never say error is 0. But the error is minimum. That minimum can be any value. Okay, finally we are able to separate the two different clusters. Perceptron or artificial neuron is trained in such a way that it finds a line which separates the different classes by adjusting the weights and bias. By adjusting the weights and the bias, you are going to separate two different clusters by using a single line. Okay. So you are adjusting the weights so that your inputs will move here and there and your separation line will move in a proper direction so that you are able to separate two different clusters using a single line. Now we are going to take an example. So here some X person. X person, he secured a rank called 2. His rank is 2. So how many hours he studied? He studied 12 hours. So he secured second rank by studying 12 hours or by spending 12 hours for study. Finally, he received 84 percentage past person. Like earlier case, his percentage is 84 percentage. After spending 12 hours, he got 87 percentage this time. Are you able to understand the problem here? So rank he secured is second rank. At current semester, he secured second rank. So how many hours he spent in front, like for education or for studying? He spent 12 hours. Till the last sem, he got 84 percentage. But when he is checked or when he got his results, now his percentage is 87 percentage. Now already he has his past data, his current data, and how much hours studied and what rank he secured. We have this data. Now see, now my input values are 2, 12, 84. So I'm taking these three as input values because I know the result also. I know the result and I just want to check how my machine learning model is working. I want to check how my machine learning model is working. Due to that, I have taken or I want to take the existing data where I have my result also. And even I have taken some weights. So what I told you, weights can be near to 0 but not 0. So I can take positive values randomly. I have used a random function. That random function randomly generated few values. Those values I have taken as a weight. Okay. As per the artificial neural concept, I am doing summation. 2 into 0.2 plus 12 into 0.6 minus 0.2 into 84. Will you calculate and let me know? Can you people can calculate this and let me know what is the value we'll be getting? 2 into 0.2 plus 12 into 0.6 plus minus 84 into 0.2. Eighty-four into 0.2. Calculate and let me know what we will get it here. This value. Quick. minus 9.2, right? Minus 9.2. Sorry. And we have passed that through some certain activation function to get the result. Now see, so we'll be getting, this is not minus 92, this is minus 9.2. Okay, this is minus 9.2. Then I'm applying that into a ReLU function called rectified linear unit. ReLU function abbreviation is rectified linear unit. This minus 9.2 I have passed through a certain activation function to get certain result. For example, I received ReLU function is, we know, maximum of x comma 0. So anyway, 0 is the maximum, I know that, but to make you to understand, generally like with 0 when you are performing, you may not get this, you may not able to understand the results. ReLU function formula just now we have seen, max of x comma 0. So max of x comma 0 is, as we received, minus 9.2 comma 0. Then the answer will be 0, right? But still I have taken output as minus 9.2 to make you to understand. I have taken this. Okay. Now this is an error. So it is saying that you'll be getting lesser percentage. So earlier case you got 84 percentage. This time if this are like this much hours you spend, then you will be getting lesser percentage, not even 84. Not even 84. But already results came. We know we got 87 percentage. Means high, more than this percentage. Okay. More than this percentage. We know we got more than this percentage. Then what happened? Your predictions goes wrong. Whatever you have predicted is wrong prediction. Then this error will be sent back to your model to tune your weights. Your weights will get updated, and again you will perform the same action, and that value will be passed through the ReLU function to get the output value. And damn sure the next, after refining your weights based on your error value, damn sure you'll be getting better or less error or better accuracy compared to your previous value. Compared to your previous value. As your actual value is 87. Then what you have started? You have started calculating your error. Error formula is, C is nothing but cost function. You may call it as error. You may call it as cost function. Error is, or cost function is, C is equal to half into y cap minus y whole square. So what do you mean by this y cap? Y cap is your predicted value. Y is your actual value. Okay. Y cap is your predicted value. Y is your actual value. So after performing this, you may get some value. This value will be returned back. Okay. This error value will be returned back. This is a cost function. See, so till now we have followed forward propagation till you have calculated your loss function. Once the loss function is calculated, then it will start backward propagation. See, the direction will be changed to backward to update your values, to update your input values. So once you got your optimized weights, again you started calculating, and again you are going to apply ReLU function. Again you are verifying your output value, and you are going to calculate loss function. And if the loss function is not ignorable value, then again you are going to be returned back and your weights get again updated. So this process will be continued until and unless your loss function value or your error value will get minimized value, approximately equal to 87%, because that is what your actual value. So till you'll be here or near to here, till the time this process will be continuous. Okay, is it clear, ma, this example, or any doubts you can ask? Any doubts you can? Any doubts, ma? Did I explain any like fast, or the speed is fine to you all? Because this is theoretical part. If you are able to understand this, then only you will be able to do the next hands-on session. Is it clear?